Germany was about to revolutionize civil aviation with the most efficient engine ever created, but the war turned it into a tool of destruction before it could carry passengers. Before we begin, let me know in the comments where you're watching this video from, so I can see how far it reached. The air of Berlin in 1936 smelled of engine oil and ambition. In the engineering workshops scattered across the German capital, men in white coats stained with grease watched pressure gauges and took frantic notes as engines roared on test benches. They were not building weapons. They were not thinking of conquests. They dreamed of something much simpler and revolutionary, making flying as common as taking a train. But between them and that dream stood an enemy that could not be fought with courage or strategy: physics itself. Every liter of fuel burned. Every kilometer gained with effort. Every engine that failed after only a few hours of operation. Civil aviation at the time was not a business. It was an act of faith sustained by government subsidies and the stubbornness of visionaries who refused to accept that the sky should remain the exclusive territory of the rich and the military. The numbers did not lie. A commercial flight between Berlin and Paris consumed so much fuel that it barely left a margin of profit. Airlines operated at a loss, trusting that someday technology would catch up with vision. The engines of the time were thirsty beasts, designs inherited from the First World War that had been optimized for brute power, not efficiency. They consumed fuel like locomotives with wings, and every hour of flight meant additional hours of maintenance. Passengers knew it. Flying was expensive, uncomfortable, and frankly terrifying. Engines coughed, vibrated, sometimes simply stopped working mid-flight. Pilots were heroes by necessity because every takeoff was a gamble against mechanical chance. Families said goodbye at airfields as if sending their loved ones off to war because, in a way, that is what it was. Germany looked at this scenario with pragmatic frustration. The country had lost the Great War barely 2 decades earlier, and with it, much of its industrial pride. But German engineering had not given up. If they could not have the largest army, they would have the most advanced technology. If they could not conquer territories, they would conquer markets. And civil aviation was the market of the future. Everyone knew that. The damn problem of the engine just had to be solved. In the offices of BMW Flugmotoren, a group of engineers led by men whose names history barely recorded began to rethink the problem from scratch. They did not want a more powerful engine. They wanted a smarter engine. Power was easy. You just had to burn more fuel, make bigger cylinders, spin propellers faster. But efficiency, that was another story. It meant extracting every gram of energy from every drop of fuel. It meant reducing microscopic friction. It meant designing cooling systems that did not steal power while cooling. It meant rethinking every component from fundamental thermodynamic principles. At the same time, at Daimler-Benz, another team worked in parallel with the same goal, but different approaches. The competition between both companies was fierce but productive. Every advance from one pushed the other to innovate faster. They shared the same national purpose: to make Germany the world leader in efficient civil aviation. The first prototypes were controlled disasters. Engines that on paper promised unprecedented efficiencies, but on the test bench disintegrated after hours. Pistons cracked under thermal stress. Injection systems jammed. Coolers boiled the coolant. Every failure was a lesson. Every minor explosion a cruel but effective teacher. The engineers slept little. They ate in the workshops. Their families saw them on Sundays when fatigue finally forced them home. But even then, their minds remained in the labs, visualizing airflow, calculating compression ratios, dreaming of valve configurations yet to exist. The great breakthrough came in 1937, not with a dramatic eureka, but with a series of incremental improvements that, combined, transformed everything. A new combustion chamber design that optimized the air-fuel mixture. A cooling system that used the flight airflow instead of relying only on heavy radiators. Experimental metal alloys that withstood higher temperatures without deforming. Pistons with redesigned rings that reduced friction without sacrificing sealing. When they assembled the first complete engine incorporating all these innovations, no one expected miracles. They had had too many disappointments. But when they started it on the test bench and began measuring fuel consumption, the numbers on the instrument seemed wrong. They checked it 3 times. There was no mistake. The engine consumed 25% less fuel than the best American engines of the time, maintaining the same power. In terms of civil aviation, that was revolutionary. It meant that a plane could fly 25% farther with the same fuel load, or carry more passengers the same distance, or reduce operating costs enough to make routes that had previously been financial fantasies profitable. Testing continued for months. They operated the engine for 100 continuous hours, equivalent to weeks of intensive commercial operation. The failure rate was minimal. Components were significantly lower than in previous designs. Stability at different power settings exceptional. It was not just efficient, it was reliable, and in aviation, reliability was worth more than gold. The reports reached the offices of Lufthansa, the German national airline. Executives saw in those numbers the future they had hoped for years. Routes to European cities that previously lost money would now be profitable. New routes to farther destinations became possible. Ticket prices could fall, democratizing access to air travel. Germany could become the center of a European civil aviation network, with Berlin as its beating heart. Aircraft designers began working on new models specifically designed around these efficient engines. Fuselages optimized for long-range flights. Cabins with more seats. Improved navigation systems for longer routes. The entire German civil aviation ecosystem prepared for transformation. In 1938, Lufthansa conducted test flights with planes equipped with the new engines. Berlin to Rome nonstop, something that previously required a refueling stop. Time and money savings were tangible. Passengers noticed the difference: smoother flights, less vibration, less noise. Pilots reported fewer mechanical problems, greater confidence in the machinery under their control. The German press celebrated the achievement. Articles in technical newspapers detailed the innovations. Popular magazines published illustrations of a future where German families would fly to their vacations as easily as taking trains now. Engineers from other countries visited German facilities, amazed by what they saw. The United States, Great Britain, France, all recognized that Germany had achieved something remarkable. But in 1939, the world changed. The clouds of war that had been gathering on the political horizon finally burst. Poland, France, the United Kingdom. Europe sank into a conflict that would consume everything in its path, including the dreams of civil aviation. The efficient engines designed to take families on vacation were quickly reevaluated in a new light. Their efficiency meant that bombers could fly farther. Fighters could stay longer in the air. Reconnaissance planes could penetrate deeper into enemy territory and return. What had been a blessing for commercial aviation became a strategic military advantage. The engineers at BMW and Daimler-Benz received new directives. Forget commercial flights. We need these engines in combat aircraft. We need mass production. We need modified versions for night fighters, long-range bombers, military transport planes. The men who had dreamed of democratizing flight now worked on machines of war. They had no choice. The country was at total war, and every resource, every brilliant mind, every technological innovation had to serve the war effort. The irony was cruel and obvious. The engines worked magnificently in their new military role. Their efficiency extended the operational range of the Luftwaffe. Their reliability reduced losses from mechanical failures. The very features that would have revolutionized tourism and commerce now served to bomb cities and shoot down enemy planes. Plans to expand civil routes were shelved indefinitely. Commercial aircraft were requisitioned for military use or stored. Factories that should have been producing passenger planes manufactured fighters 24 hours a day. Engineers who should have been optimizing cabin comfort designed mounts for machine guns. During the war years, technology continued advancing, but in directions very different from those originally planned. More powerful engines, yes, but also more specialized for combat. Injection systems optimized for violent maneuvers, not stable long-distance flights. Alloys designed to withstand combat damage, not maximize operational efficiency. Some of the original engineers kept the civilian designs in their drawers, hoping for the day they could resume that work. Others resigned themselves to the reality that their creations would never serve the purpose for which they were conceived. A few secretly hoped the war would end soon to rescue the dream of efficient civil aviation. It did not end soon. When it finally ended, In 1945, Germany was in ruins. The engine factories had been bombed repeatedly, the test benches destroyed. The engineering teams dispersed, deceased, or captured by the victorious powers. Technical documentation confiscated by Americans, British, and Soviets, each eager to extract technological secrets from the rubble of the Reich. The efficient engines that should have powered a golden age of German civil aviation ended up studied in foreign laboratories. American engineers examined combustion chamber designs. British technicians dismantled cooling systems. Soviet specialists copied alloys and manufacturing processes. The innovations were not lost, but their origins blurred. In the 50s and 60s, when civil aviation finally experienced the boom Germany had anticipated in the 30s, many of the technologies that made it possible had roots in those German pre-war engines. But no one mentioned it. History belongs to the victors, and acknowledging that German technology had contributed to civil progress did not fit post-war narratives. Lufthansa was re-established in 1955, a decade after the war's end. It started anew from scratch, buying foreign aircraft and engines, mostly American. The German engineers who survived worked on reconstruction, some in their own country, many others immigrating to the United States, Great Britain, or the Soviet Union, where their knowledge was valued while their nationality was conveniently forgotten. The man who had led the original BMW team died in 1962, in relative obscurity. There were no obituaries in the international press. No books were written about his contribution to aviation. His name appears in some archived technical documents, but not in popular history books. Yet, his legacy flies every day. Every time a commercial plane crosses the ocean with efficiency that would have seemed impossible in 1930, it carries echoes of those innovations from Berlin. Every time an airline calculates routes based on fuel efficiency, it stands on foundations established in those German pre-war laboratories. Modern passengers do not know this. They board their flights, complain about legroom, check their phones during takeoff, completely unaware that the affordable price of their ticket is partly due to innovations conceived nearly a century ago by men who never lived to see their vision realized. History could have been different. If the war had not broken out in 1939, if political tensions had been resolved diplomatically, if 1,000 different hypotheticals. Berlin could have been the center of world civil aviation in the 40s. Fleets of efficient planes might have connected Europe much earlier. The democratization of flight could have happened a decade sooner. But history does not accept conditional clauses. What happened, happened. The engines that should have taken families to the beach carried bombs to cities. The technology that should have united nations served to separate them more violently. The dream of making the sky accessible to all was hijacked by the nightmare of making it deadly. Today, in specialized aviation museums, specimens of those engines are occasionally displayed. Informational plaques mention their technical specifications, their use during the war, perhaps a brief note on their civilian origins. Visitors pass by quickly, more interested in dramatic combat planes than in the engines that powered them. But if you watch closely, if you know the whole story, you can see in those pieces of metal more than military technology. You can see the ambition to make the world smaller and more accessible. You can see the sleepless nights of engineers who believed they were building a better future. You can see the exact moment humanity chose destruction over progress. It was not the engineers' fault. They built the best they could with the purest intentions. It was not the technology's fault, which is morally neutral, a tool that serves whoever wields it. It was the fault of a historical moment where political decisions channeled human genius towards annihilation instead of creation. The efficient German aircraft engine exists in history as a symbol of lost opportunities. A reminder that technical progress does not guarantee human progress. That the best intentions can be perverted by the worst circumstances. That the future is not inevitable but fragile, dependent on decisions we sometimes make without fully understanding their consequences. When you board a plane today and travel to another continent for a price your grandparents would have considered impossible, you are inheriting a dream that began in Berlin before the war. A dream interrupted, diverted, appropriated by others, but one that finally came true, though not in the way or by the people who originally conceived it. The engineers of 1936 wanted to change the world. They did. just not as they had planned.